Imagine an electric car that can travel up to 1,000 kilometers on a single charge, recharge in a fraction of the time, and still maintain strong battery performance even after years of use. If that sounds like the future, Toyota may be working to make it a reality. For years, Toyota has been developing solid-state battery technology, and now this technology is once again attracting massive attention. But the real story isn't just about a longer driving range. It's about what Toyota is changing inside the battery itself and why that could potentially reshape the entire EV industry. Could Toyota's new battery technology challenge the dominance of Tesla, BYD, and other major EV manufacturers? What makes solid-state batteries different from today's lithium-ion batteries? And most importantly, when could this technology actually reach mass-produced cars? In this video, we'll break down Toyota's solid-state battery technology, including its potential range, charging speed, safety, durability, cost, and the realistic timeline for production. But before we uncover what Toyota may have been working on for years, make sure to subscribe to the channel and turn on notifications so you don't miss our next deep dive into the technologies that could change the future. Toyota has been building cars for generations, and its reputation for reliability is recognized across the world. But when it comes to the electric vehicle revolution, one important question remains. How strong is Toyota's position right now? To understand that, we first need to look at fully electric vehicles. These are cars powered entirely by batteries, without relying on petrol or diesel. Based on the 2025 to 2026 figures, Toyota's battery electric vehicle sales are growing steadily. However, compared with the company's enormous overall sales, fully electric vehicles still represent a relatively small portion of its business. During the first 6 months of 2026, from January through June, Toyota sold roughly 190,000 fully electric vehicles globally. That's about a 35% increase from the same period a year earlier. But there's another number that puts this into perspective. Toyota sells more than 10 million vehicles in a typical full year. So, despite the growth, pure EVs are still only a small part of Toyota's overall business. The company is clearly moving toward electrification, but it isn't rushing to abandon its existing strategy. The picture changes dramatically when we include hybrids and plug-in hybrids, along with fully electric vehicles. Toyota groups these technologies under the broader category of electrified vehicles, and this segment has reached extremely high sales levels. More than 5 million electrified vehicles are being sold by Toyota each year, and in just the first half of 2026, the company sold more than 2.7 million. That means electrified vehicles now represent more than half of Toyota's total sales. Put simply, roughly 1 out of every 2 Toyota vehicles sold uses some form of battery-powered technology. And that tells us something important about where the company is already positioned in the transition toward electrification. But Toyota's EV performance isn't the same everywhere. Europe has become one of the stronger markets for Toyota's electric vehicles. In certain European markets, sales have more than doubled as consumer demand for EVs continues to rise. The United States has also shown strong growth. Toyota sold around 22,000 fully electric vehicles there during the first half of the year, which was more than twice the number sold during the same period last year. China, however, presents a much tougher challenge. Chinese automakers are producing increasingly capable EVs at highly competitive prices. That has created intense pressure for international manufacturers, including Toyota, and the company's pure EV sales in China remain relatively modest. So, what is Toyota planning for the years ahead? Unlike some automakers that are putting almost all of their attention on battery electric vehicles, Toyota is taking a broader approach. The company believes that different regions have different transportation needs. Some countries still have limited charging infrastructure. Some drivers regularly travel extremely long distances. And in certain markets, electricity costs can make fully electric vehicles less attractive. Toyota's answer is what it calls a multi-pathway strategy. Instead of betting everything on a single technology, Toyota plans to continue developing hybrids and plug-in hybrids while gradually expanding its fully electric lineup. The company has also set ambitious targets for EV growth by 2030, including plans to reach annual sales of around 1 million or more battery electric vehicles. However, hybrids remain a major part of the company's current strategy. They are already popular with customers, can be sold in large numbers, and remain an important source of revenue for Toyota. Now let's look at something that directly affects the experience of driving an electric Toyota. Range. Range simply means the distance an EV can travel after being fully charged. Toyota's main battery electric lineup includes the BZ series, which was previously known in many markets through the BZ4X name. Depending on the market, battery configuration, wheels, and testing standards, the claimed range can vary considerably. In the United States, some versions offer an official range of roughly 480 to 500 kilometers. In Europe, certain versions can claim figures closer to 550 to 600 kilometers. But official laboratory numbers don't always represent what a driver experiences on the road. Real-world range can be affected by temperature, driving speed, traffic, road conditions, tire choice, and even how aggressively the vehicle is driven. Under normal conditions, the practical range can therefore be somewhat lower, often falling somewhere around the 450 to 550 kilometer region, depending on the model and circumstances. Toyota has also been working on improvements to its electric powertrain, including changes to the battery and motor designed to increase efficiency and driving range. This is significant because Toyota's earlier EV offerings were sometimes criticized for falling behind competitors in range and charging performance. The company now appears to be working aggressively to close that gap. But this brings us to an even more important question. What battery technology is Toyota using right now? And how different is it from the solid-state battery technology the company is developing for the future? To understand why Toyota's solid-state plans could be so important, we first need to understand the batteries already being used in today's vehicles. Whether we're talking about a fully electric car or a hybrid, the battery is one of the most critical components of the entire system. At present, Toyota primarily relies on conventional liquid electrolyte lithium-ion battery technology for its battery electric vehicles. This is broadly the same basic battery architecture used across much of today's EV industry. The term liquid refers to the electrolyte inside the battery. This material allows charged particles, known as ions, to move between the battery's electrodes during charging and discharging. Toyota uses this type of lithium-ion technology in its current battery electric vehicles, including models in the BZ family. And this is exactly where Toyota's next major technological step becomes interesting. Because instead of simply improving the existing liquid-based battery, Toyota has been working toward a fundamentally different design, the solid-state battery. Some of Toyota's current batteries use a prismatic design, which means the individual battery cells have a flat, rectangular shape rather than the familiar cylindrical form. Toyota is also developing newer battery designs based on a bipolar structure. Put simply, this changes the way the internal components are arranged, allowing the battery to deliver more power while making better use of the available space. The result can be a battery that is more compact and potentially lighter. Hybrid vehicles have followed a somewhat different path. For many years, Toyota's hybrid lineup, including older generations of the Prius and several other models, relied heavily on nickel-metal hydride, or NIMH, batteries. The technology may be older, but Toyota has proven that it can be extremely dependable. NIMH batteries have a strong reputation for durability and can continue operating reliably across a wide range of temperatures, including very hot and very cold conditions. However, Toyota has gradually been shifting some of its hybrid vehicles toward lithium-ion batteries. Newer hybrid models increasingly use lithium-ion technology because these batteries generally offer a better combination of lower weight, higher power output, and faster charging capability. As Toyota continues updating its hybrid lineup, more models could eventually move away from traditional nickel-based batteries. Battery safety is another area Toyota takes very seriously. The company uses systems designed to monitor and manage battery temperature, helping prevent excessive heat buildup and reducing the possibility of thermal problems. There is also an important difference between hybrid and fully electric vehicles. A hybrid doesn't need an enormous battery because its petrol engine can provide additional power. A pure EV, on the other hand, depends almost entirely on its battery to move the vehicle, which means it requires a much larger energy storage system. Another part of Toyota's battery strategy is manufacturing and partnerships. The company produces some batteries through its own operations while also working with specialized partners for other battery technologies. Across both areas, the objective remains the same: increase driving range, improve charging speeds, extend battery life, and bring costs down. Today's lithium-ion battery has become a highly developed and proven technology. Millions of vehicles around the world already depend on it, which is one reason Toyota continues to use it as the foundation of its current EV strategy. But Toyota isn't stopping there. So, what exactly is Toyota's solid-state battery? This is where the story becomes much more interesting. Toyota has been discussing solid-state batteries for years, but the basic concept is actually easier to understand than it sounds. Think about the batteries used in most electric vehicles today. Inside those batteries is an electrolyte in liquid form. Lithium ions move through this liquid material between different parts of the cell as the battery charges and discharges. A solid-state battery changes one of the most important parts of that design. Instead of using a liquid electrolyte, the battery uses a solid electrolyte. Toyota's solid-state battery research has focused on a sulfide-based solid electrolyte. So, in very simple terms, the liquid pathway used in conventional batteries is replaced with a solid material that allows the ions to move. And this change could have major consequences. The first big question is obvious. How much more range could Toyota's solid-state battery actually provide? Toyota has set a target of roughly 1,000 kilometers of driving range for its initial generation of solid-state battery technology. That would mean significantly fewer charging stops during long-distance journeys. And Toyota's ambitions don't stop there. The company has discussed a future generation that could potentially push the target to around 1,200 kilometers on a single charge. For comparison, many mainstream electric vehicles today offer somewhere in the range of roughly 400 to 500 kilometers, depending on the model and testing standard. If Toyota can achieve its targets in a production vehicle, that would represent a dramatic improvement. Of course, real-world range will never depend on the battery alone. Vehicle weight, aerodynamics, battery size, road conditions, temperature, speed, and driving behavior will all affect the final result. Still, Toyota's objective is clear: make long-range EVs capable of approaching the 1,000-kilometer mark. Premium vehicles, potentially including Lexus models, are expected to be among the candidates for this technology as it moves toward production. But how does the battery actually work? The basic principle remains similar to today's lithium-ion cells. During operation, lithium ions move between the battery's electrodes. The major difference is the material through which those ions travel. In a conventional battery, they move through a liquid electrolyte. In a solid-state battery, they move through a solid electrolyte. This different architecture could allow engineers to pack more energy into a given amount of space. That property is known as energy density. In simple terms, higher energy density means you can potentially store more electrical energy without making the battery proportionally larger. And that creates several possible advantages. A battery could become smaller or lighter while maintaining the same amount of usable energy. Or, engineers could use a similarly sized battery but store considerably more energy inside it, giving the vehicle greater range. Then there's another feature that could completely change the EV experience: charging speed. Toyota has targeted charging from approximately 10% to 80% in around 10 minutes for its solid-state battery technology. If that target is achieved in real-world production vehicles and supported by sufficiently powerful charging infrastructure, a long charging stop could become much shorter. Instead of waiting 30 or 40 minutes, or potentially even longer, you could spend roughly the time needed to grab a coffee and return to a vehicle with a substantially higher charge. But range and charging aren't the only reasons solid-state batteries are attracting attention. Safety is another major part of the equation. Conventional lithium-ion batteries use a liquid electrolyte, and extreme heat or internal damage can create serious battery management challenges. A solid-state design eliminates the conventional liquid electrolyte, which could reduce issues such as leakage and potentially improve stability under certain conditions. That doesn't mean solid-state batteries are completely immune to fires or other failures. They still contain highly reactive materials and require sophisticated engineering and safety systems. But replacing the liquid electrolyte could give engineers a different and potentially safer foundation for the next generation of batteries. Toyota has been researching this technology for many years and has accumulated a substantial portfolio of patents connected to solid-state battery development. And the company's objective goes far beyond simply increasing the number on a range chart. Toyota is also trying to develop a battery that is lighter, more compact, faster to charge, more durable, safer, and ultimately cheaper to produce at scale. Toyota's goal is not simply to make the battery charge faster. The company is also trying to improve its safety and overall performance. If Toyota manages to make this technology work at mass-market scale, two of the biggest complaints surrounding electric vehicles could potentially become much less serious: limited driving range and long charging times. But there is an important point we need to keep in mind. Toyota's solid-state battery is not currently powering the company's regular production vehicles. The technology is still being developed, tested, and prepared for mass manufacturing. Turning a promising laboratory design into millions of reliable batteries is a completely different challenge. Toyota believes, however, that if it can overcome those manufacturing hurdles, solid-state technology could represent a major step forward for electric vehicles. At its most basic level, the difference between today's conventional battery and Toyota's future solid-state battery comes down to one key component. Today's batteries use a liquid electrolyte. Solid-state batteries use a solid electrolyte. That seemingly simple change could unlock several potential advantages, including greater energy density, longer driving range, faster charging, and potentially improved safety. So, where does Toyota's solid-state battery stand today? This is probably the most important question. There has been enormous excitement surrounding Toyota's technology, but separating the company's targets from what is already available is essential. At the moment, Toyota is moving through the pilot production and manufacturing preparation stages. In other words, the technology has progressed well beyond the basic research phase. Toyota has been testing the battery and working on small-scale production, but it has not yet reached the point where millions of units are rolling off factory lines. And this is where one of the biggest challenges appears. Building a battery in a laboratory is one thing. Building millions of identical batteries with consistent quality, low defect rates, and acceptable costs is something else entirely. Toyota is therefore working with its partners to install specialized manufacturing equipment, refine production techniques, and improve quality control. The objective is simple. When mass production finally begins, the number of defective cells needs to be as low as possible. Because this is a completely different battery architecture, developing the manufacturing process naturally takes time. So, when could we actually see one inside a Toyota vehicle? Toyota has been targeting the 2027 to 2028 period for the introduction of its solid-state battery technology. That means the first production vehicles equipped with these batteries could potentially appear within the next few years. However, there's an important distinction. A launch in 2027 or 2028 does not mean every Toyota EV will suddenly receive a solid-state battery. The technology will most likely appear first in higher-priced premium vehicles, potentially including Lexus models. Initial production could also be relatively limited. Only after Toyota gains more experience and improves manufacturing efficiency would the technology have a realistic path toward cheaper, higher-volume vehicles. So, at least in the beginning, solid-state batteries are likely to remain a premium technology. Toyota is also working with outside partners to make this transition possible. One important area is the production of the solid electrolyte itself. Toyota has been collaborating with other companies and preparing manufacturing infrastructure in Japan. A production facility being developed with partners is expected to be ready around the end of 2027. Toyota has also received approval from the Japanese government to proceed with production plans. Company officials have continued to indicate that the development program remains on schedule. But we should still keep our expectations realistic. There is currently no Toyota production vehicle available to ordinary customers that uses this solid-state battery. Some test vehicles may be used internally for development and evaluation, but consumers cannot simply walk into a dealership and buy one today. And there's another reason for caution. Toyota has announced timelines for advanced battery technology in the past, and some targets have subsequently been adjusted. So, while the current 2027 to 2028 target is important, it should be viewed as a planned timeline, rather than an absolute guarantee.